Alright class, hopefully your test went well. Today we're going to just do something that you've seen already from Algebra 1, but we're going to review it. Solving 2x2 systems graphically and algebraically. A system of equations is when you have two different equations with the same unknown variables. So it's usually in the format of ax plus by equals c and dx plus ey equals f. A solution set are the answers. Instead of writing x equals and y equals, we usually list them as an ordered pair, because usually when you are doing a system of equation, you're finding an intersection. So what that looks like in general, one solution is if you have one line that goes like this and one line that goes like that. Where they intersect is the only spot where it's the only spot where you'll find the solutions that satisfy both lines. Infinitely many. If you get that, that turns out to be the same exact line. Okay, so basically both equations are the exact equation. And finally, no solution is when you have parallel lines. The lines will never intersect, so therefore they cannot have a solution. Okay. Now we're going to do methods. We have the substitution, elimination, and solve by graphing. Elimination is also called linear combination, if you learned it that way. For substitution, you want to solve for one of the variables, kind of like what we are doing for literal equations. And the best thing to solve for would be the one that doesn't have a coefficient attached to it. Okay? In this case, that would be x. So I'm going to solve this one for x. I get x is equal to 2 minus 2y if I move the 2y over. Okay? Now I can sub this in for x in the other one. So this becomes 5. And then my sub in is 2 minus 2y minus 3y equals negative 29. And now you can just go about solving, because now there is only one equation with one variable, which is good. So distribute that. Combine your like terms before you move anything. Negative 13y plus 10 is equal to negative 29. Negative 13y is equal to negative 39. So y is equal to positive 3. Now the nice thing is we've already solved for x, so we can plug that back into the original equation that we solved for. And you get x is equal to 2 minus 2 times 3. So that would be 2 minus 6, which is negative 4. So my solution set, though, I want to write as an ordered pair. These graphs intersect at negative 4, comma 3. Okay? Alright, so that's how you do, that was substitution. Now we're going to do elimination. Elimination is when you get one of the variables to have the opposite, the same number but opposite signs, so when you add them they cancel out. So for instance, I want to turn this 3 into a negative 6. So I'm going to multiply this whole equation times negative 2. And then I'm going to rewrite it down here. So negative 2 times 3 is negative 6a minus 8b equals negative 20. Now, this is actually going to be a special case. So I did this. Now I'm going to add these two together. You get 0 plus 0 equals 0. Everything cancels out. So 0 equals 0. That is a true statement. This is a scenario when you get this, that you will have infinitely many solutions. They're basically the same line, it's just that was multiplied by 2. Okay? Alright. Solve using a method of your choice. I prefer to do elimination for 2x2s. So I look at this, and again, I see 2x and 6x. So I'm going to try to turn this into a negative 6 by multiplying the top by negative 3. I'm going to rewrite it underneath it now. I get negative 6x, negative 9y equals negative 45. Okay, so in this scenario, cancel, cancel, you get a 0 on this side. Add these together, you get negative 35. This is a scenario where you have no solution, because this is a false statement. So this is no solution because we have parallel lines, but they're not the same line. Okay. Now this is a weird case because there are 3 equations with 2 variables. So with this, you want to know where they all hit. The best way to look at that is to sketch a graph. If you want to do it on your calculator, you're going to have to solve all of these for y. I'm going to just use standard form. When for this equation, when x equals 0, y equals -5. And when y equals 0, you get x equals 5/3. So this first line, I'll just put some tick marks up here. Alright, so this first line I'll do in blue. You get the intercepts at -5, 1, 2, 3, 4, 5, and 5/3, which is about there. It's 1 2/3. So one line looks like this. And you have to be kind of accurate so you know, at least to look at it. On the calculator it's probably more accurate, but again, for this purpose I'm just going to do it on here. For this line down here, when x equals 0, y equals 7/3, and when y equals 0, x equals 7/2. Well, that's 3.5. And this is what, 2 1/3? 1, 2 1/3. So I have a line that goes through those 2 points. And finally, and again, this is all just quick graphs that we did before with standard form. This third line, when x equals 0, y equals -9/4, and when y equals 0, x equals 9. Alright, so 1, 2, 3, 4, 5, 6, 7, 8, 9. And then -9/4, so 1, 2, and 1/4. If I connect those dots, you should see that there is not one intersection point for those three lines. They would all have to meet at one spot. They don't, so in this case this is another no solution. And again, you can say the three equations don't intersect at one spot. Okay. Last thing we're going to do is solve by graphing with the calculator, because these are going to give us sometimes not nice answers. So, solve the following system by graphing on your calculator. Sketch a graph, label your point of intersection. Well, in order to sketch a graph, you need to solve for y. So I'm going to do this one first and say I have -3y is equal to -2x plus 1. Y is equal to, divide by -3, 2/3 x minus 1/3. So this is going to be my y1. Down here, I'm going to solve this one for y. I get y is equal to -4/5 x plus 3/5. So those are my two y's. So at this stage, you go to your calculator. I'm going to bring my calculator up. And you want to type in your y1 and y2. So 2/3 x minus 1/3. And then here we have -4/5 x and plus 3/5. Okay. And always zoom 6 because it'll probably be in the standard window. And then these are my two equations. One hits there, one hits about there. You can't assume what that dot is, so I'm going to sketch this first, and then we'll come back to it. So this graph looked like this. There was a line coming down. The negative slope one was the red one, and it hit about there. Just kind of be semi-accurate. We're tracing it, so, and then this one came up and hit like right there. So there's a point there that we need to find, and we don't know if it's on the 0 or not. We have to actually check it. Here's how you do this in the calculator. It's very simple. We want to find the intersection point. So just like it says on your sheet, you hit second trace, kind of second trace, and if you look down at number 5, it says intersect, which is what we want. So I hit 5, and then move the cursor kind of close to where you want the intersection. Then you have to hit enter 3 times. It wants you to do the first curve, the second curve, and guess. But once you hit it for the third time, it says the intersection and then tells you the numbers. So this intersects at x of 0.636 and 0.09090909. So for this purpose, just round to the nearest thousandth. That's what it says on the sheet. So we have 0.636. So the point that it intersects is 0.636, comma 0.091 when you round. So that is the solution to the problem right there. That's all you have to do. You have to show your two equations you typed into your calculator, the sketch, and the final solution. Alright, let's do one more. This one you don't actually need to graph though, because you'll see what happens in a second. Solve for y. This one's already solved for y. Divide by 4, you get y is equal to 1/2 x minus 7/4. Well, hopefully you guys notice when you look at these two that their slopes are exactly the same. And you can graph these by hand if you want. In this case, because guess what happens? Minus 7/4 is about here, and 1/2, kind of looks like that. And the other one's at -3, which is a little bit lower, but again, it has the exact same slope. So if they have the same slope and they don't start at the same place, what kind of lines are these? They're parallel lines, which means that you are going to have no solution. Okay, so that is graphing, and that is solving different 2x2 systems.